So let's move to the move forward on in module 3. So module 3 has a lot of small topics. So I'll talk about most of them, and I will not get into the details because they are also like one or two paragraphs only in the content. So let's start with a topic which is called as explainability. It may sound trivial, some of these, they are like very basic, but for the sake of completeness, or for the sake of coverage, I'll try to touch at least all of them one by one. So explainability, interpretability, and transparency. So what it means is that you have a model M, and so there is some input data that goes in, and you get some kind of an output, which can be classification, which can be suggestions, which can be numerical stuff, etc. Okay, so there is an analysis that comes out. So as you can intuitively think, explainability means that the model needs to be explainable, and interpretability means that it needs to be interpretable. And both of these things mean that if a model is explainable and interpretable, that means that there is some form of a transparency that is established. Now these are confusing terms, so let me tell you that there is something called as a model at rest and model in motion. Okay, so what I mean by model at rest is that we have created a model. Okay, let's not think whether it is a decision tree or a random forest or a regression or a linear regression or a logistic regression kind of a model, or a more complex neural network kind of a model. So if I am able to make the behavior of the model if I can explain this to a human, mostly a regulator, mostly somebody from the compliance team, that this is how my model takes say, let's suppose 5 different parameters, and it uses them in that kind of a proportion, and this is how it, let's suppose it's a credit risk model, I say that okay, this is how it takes into account the earlier credit score of that individual, the credit history, the age, etc., and this is how it says that the credit worthiness or some kind of a score, that this is how the person is worthy of credit or not. So that's called the if I'm doing this for model at rest, that's called the interpretability. Okay, so interpretability means that I am able to interpret the model and able to tell that person. Now model in motion means that there is this model, and for some particular input you are getting some output. Okay, so it's already in motion, so it's already produced the output. Here it has not produced the output, we are just telling that this is how you can interpret. Now based on the output that you have received, you are trying to go back to the individual and say the model has produced this output, whatever it has produced, because of so and so reasons. This is called explainability. So this is after the event has already occurred, after the model has already predicted or classified, you are trying to explain why such a output has occurred. And interpretability means that when a model is at rest, it is more of a mathematical model, then you are trying to tell everybody that this is how the model is designed, and this is how my model is going to be used. Okay, so this is about explainability, interpretability, transparency. The next reading about is called as a black box problem. Again, a very basic thing. It means that as your models become larger and larger, okay, so these days, and most of the times, a larger model means a better accuracy. Otherwise, why will anybody use a larger model? Some of these LLMs have 1 trillion parameters. Okay, so when you have 1 trillion parameters, it is almost impossible to understand. Even the person who would have designed these LLMs, if we go to OpenAI, or we go to Altman and say that, hey, you have designed GPT-4o or whatsoever, can you as a designer of the algorithm tell me how this entire thing works? Or if I say that if I am giving you a prompt P without actually going through the model, can you tell me using a pen or a paper or any offline tool, what is the output going to be? So that person is not going to be, anybody in the world cannot predict the output and then look at the output here and predicted output and then tell that whether these are same or not. So the models have become so intuitively large that we have got into this problem of black box problem. Okay, so this is a kind of a black box, and we don't know how everything operates. So that's the black box problem. Very, very simple. Now the other thing is opaqueness. This is also very simple. What it means is that the end users, when they are trying to interface with some of these AI things, whether it is you going to Amazon and looking at the recommendations, or you browsing your media on Facebook or YouTube Shorts or Reels, and the recommendations of the videos, etc., how it understands your behavior and gives you some kind of a recommendation is entirely opaque to you. And what kind of a data it is actually consuming from your interface, whether it is your eyeball movement, whether it is your intensity of how often you see something, how often you dislike, or whatever, whatever is the modus of that particular system to understand your behavior, all that is hidden to you. Most of the time, now that the regulations have become stricter, but most of the time these algorithms will not take an explicit approval from you that this is how we are doing this collection, whether you are okay, not so okay, etc. So that means that these models are very, very opaque. And then let's go to last part of explainability, which is called as XAI or explainable AI, where there are a lot of new methods. You can read this in detail, but I'll just touch this slightly, which says that let's suppose there is an algorithm which is a complex algorithm. Let's suppose there is a neural net algorithm, and you want to make it explainable. So now you cannot go back to those 1 trillion parameters. Let's forget about LLMs for a while, but even if there is a classification algorithm which is huge and impossible to understand, how do we actually make it explainable? So there are multiple methods, like something else called as a weight of evidence, or there is something called as a SHAP, where you get some shapely values, or line, and there are more methods. What they try to do is they try to reverse engineer these models and try to give you some kind of an indication. Like in the weight of evidence, it will tell you that if there are n number of parameters that the model can possibly consume, it will tell you that the weightage of these parameters is going to be in this proportion. Now it doesn't understand this model, but it is trying to estimate the behavior of this model using some kind of an external database method. Shapely values also are similar to weight of evidence, where you are trying to tell that the method is slightly different, where what it does is it's going to take, let's suppose there are n weights and n parameters, so it says that okay, let me keep p1 to pn minus 1 as constant, and then I am going to vary my last parameter. So based on how the variance of Pn is going to change my output, it is going to create a Shapley value for say Pn, and then Pn minus 1 to say P1. So it is also going to give you an indication of in what intensity all these values are correlated. And then I think if I'm not wrong, line is also very similar, which says that it tries to simplify these models and say that hey, this neural network model is equivalent to this logistic regression, and this is how it behaves. Okay, so now the problem with all of this is that it tries to oversimplify these algorithms, and this simplification may or may not be the true representation of the algorithm that we are trying to reverse engineer. Otherwise, if it was a true representation, then we would have taken those simplified methods itself. Okay, so that brings us to the end of the explainability, interpretability reading. The next are very, very small, like 3 to 4 sentences each on a couple of things which I will touch. The first one is autonomy. So autonomy means that if I have to take a decision, then I should that decision needs to be autonomous. When I say autonomous, it needs to be my own decision. So which is very, very difficult these days, because when your model or any form of automation is prescribing to you that this is what you should do, then there is some kind of some people call it as an automation bias, that if you have to go against that recommendation, let's suppose there is a credit risk model that gives you an indication that this person should not be given credit, but you feel mathematically, or you are convinced looking at his or her documents, that the loan can be provided, but there is so much of an automation bias that you may still say that no, I should trust the system and not do this, approve this loan application. So the autonomous behavior of the mankind is at question. The second one is on manipulation. Okay, so manipulation is also similar to autonomy, which says that because of models becoming so powerful, because of humans interacting with the digital information so much, so often, there is a likelihood that your mind is manipulated, whether it is elections, whether it is the choice of the choices that you make, choices to eat, choices about your values. All of that is heavily manipulated. So if the system understands that you are, say, suffering from a particular disease, or you are prone to some kind of a genetical disorder, it is going to give you so much of information around say consumption of organic wheat, or in the first place, it may say that wheat in the first place is not good for you, you should switch to millets, etc. And then you may change your lifestyle and start not consuming wheat. So your choices gets manipulated by the recommendation that comes to you digitally. Okay, so all these readings are very, very small readings, like as I said, 4 to 5 sentences, so we don't have to boil the ocean for each of them, but it's better that you also read them while you are going through the course. Then is your safety, wellness. Okay, which again is very, very basic, which says that the data that gets collected Uh, so this data, whether this data is safely kept or whether this data is not so safely kept, and whether your safety is at stake. So you would have heard that so much of information of credit card is lost, so much of information about Aadhaar is lost, but thanks to things like GDPR and things like the EU AI Act, etc., the legislations are becoming very stronger, and it also talks mostly about the safety of individuals. The next one is the next reading is around reputational risk. Okay. So the problem is that as these companies or industries start leveraging AI more and more, because we know that in today's world, not using AI is not an option. Okay, so the companies will have to use AI. That's no brainer. But as and when they use an AI, and since it is not an employee or a person that can be punished or that can be made accountable for if there is a wrong decision that has happened. So there is an example where I think Apple in collaboration with JP Morgan Chase, or the Chase Bank in the US, they offered a credit card, and it had the credit worthiness check was all algorithmic, and after some point of time it realized that the credit limits that they gave to women were significantly lower than men, even if they had the same financial status. And then it was sent to the court, and then they had to pay some fines, etc. And since then Apple has not collaborated in that kind of a partnership or that kind of an algorithmic decision making. So because the reputation of the company comes at risk, and most of the companies, they take years and years, sometimes hundreds of years to build that brand, and if that brand goes down because of incorrect use of an algorithm, so it can create a lot of problems. So the reasons why people can get into algorithmic reputational risk is, one is because if there is a privacy breach. Okay, so if you trust Microsoft or Meta, and you share all your data, whether it is your PII data on social media, and then that gets stolen or that gets consumed by not so great elements in the society, it can create a problem. The second is the algorithmic bias, which is what I was telling you in case of Apple, where the algorithm was preferential to one particular gender, and that's how they were able to, they got into that kind of a legal problem. And the third one is the explainability, or maybe I will say no explainability available, because if the models were explainable and they were able to find out or pinpoint that this is why my algorithm is more biased for men rather than women, they would have fixed it. But even after realizing that there is a problem with some of these complex models, they are still not able to fix it. So they can only just dump the model, dump the line of business, dump that business, and move on. The fixing of the model can only be possible when the models are more explainable. Okay, so those are some of the reasons that the reputational risks come in the first place to all the companies. And then there are, they also, GARP also tells there are two types of risk, which says as competence and value alignment. Okay, so there is a competence risk, and then there is a value alignment risk. I'll tell you what this means. So competence means that the company did not have the technical expertise or the operational expertise to run this kind of a business, okay, or run this kind of a business using that sort of an automation, which is something that has happened in Apple's case in my example. The problem with the value at alignment is that the company knew, okay, so in this case there is a lack of, I'll say, expertise. And in this case there is an intention that the company knew, but they did not have the intention to tell the consumers. So there was this Cambridge experiment where I think they collected some data from people who had filled some kind of a questionnaire on social media, and then they used that information to send them some kind of a political messages to influence some elections, etc. So in this case, the developer or the designer of the algorithm knew that this is what they are doing, but they intentionally use that data and they were trying to influence or market some particular messaging. Okay, so that's the difference. The next reading is around this is on so now that we understand that these are the reasons, these are the types, how do we manage these risks? So since the reputational risk in a company is very, very important, so how, as I said, that not using AI is absolutely not possible. So how do they manage these risks? The first foremost is that they should be willing to change. So adaptability. So if there is a problem that is encountered, if there is a problem that is notified, whether in internal testing or external testing or from the users, they should be adaptable to change. Okay, so that's the first thing. Then there is a lot of work being done, and we will discuss this in module number 4, which is on the ethics of AI or AI ethics. So there is a well established medical ethics, okay, where the doctors or all the medical community abides to some basic standard guidelines, I would say ethical guidelines, that this is what needs to be done in spirit, and profit and business should not be the only intent. Similarly, in the field of AI also there are a lot of ethical guidelines. We will talk about this in module 4. So all of those things needs to be taken care of. Then the third one is the communication, and this is more to do so with your value alignment, that whenever you are trying to make use of AI or whatever you are trying to do, you have to keep the stakeholders informed. So whether they are the end users or they are your investors, you need to be very crisp in your communication and say that this is what we are doing, and this is, if it carries some risk, that those kinds of disclaimers should also come in place. And the fourth one is the risk analysis or the crisis management needs to be done as per the law of the land, whether it is the European AI Act or anything else for that matter. So this is what they can do. So that takes care of the reputational risks. Let's come to the next one, which is, some of these risks are also kind of funny. Okay, it's called existential risks. Funny, philosophical, or hypothetical, I don't know, I leave it to you, but there are it's like from reality we are getting a little into hypothesis, or very becoming very futuristic, or more like your Hollywood films. They're saying that okay, we are in 2025 and today AI can code, AI can write marketing material, AI can possibly draft your emails, okay, AI can probably translate. So the job of the software engineer, the job of the marketing people, or the job of your stenos, etc., all of those are at risk. Okay, so if everything is done by AI, what are humans going to do? And there is going to be social unrest. There can be there can be a lot of problems that can come because of all of this. And this AGI, which is called as artificial general intelligence, is not very far. So there are people who say that by 2050 we will come to AGI. There are some people which say that it will come sooner. Then there are some people which will say that it will come further. Today AI is successful in some kind of narrow things which are specified, which are domain centric. But as we become agentic, as we become more generalized, if there is AGI that comes in place, there can be an existential risk to the human community in itself. Okay. Then there are global challenges. Say global risks. Now these global risks can be, let's say, economic risks. We are seeing some elements of economic risks even now when we in this today's age. People are losing jobs, operational jobs, maybe customer care, call centers. Those kinds of jobs can probably get eliminated. A lot of paper pushing jobs, a lot of managerial jobs where you just consolidate information for 5 different places and send it across, scheduling jobs, etc. So if that happens, then people will lose jobs, people will not have money, and there is a kind of an economic risk that people will go through. Even people with or without AI skills can also have an issue. People with the AI skills may still be able to retain jobs and not without AI skills. Then the second problem is the global inequality. If you see, most of the services, AI services, are provided by very few countries. Mostly it is US, and then outside of US there are some companies in Europe which are also giving some of these services. Majority is US, and then slowly and steadily China is also coming almost at par with US, and India is also slowly focusing to build their own indigenous LLMs and things like that. See, most of these researches are very, very expensive. The GPUs, the compute, the power, all of this. So there will be countries like countries in Africa, countries in Southeast Asia, etc., may not have so much of resources, so much of data, so much of engineering, so much of scientists that they can build their own models. And if the entire data of the world is contained only by few countries, there is going to be a lot of global inequality. We have already seen a digital divide across various countries. Some people are more digital, some people are less digital. Then there will be an AI divide. So that's the global inequality that it talks about. Then it also talks about misinformation. Okay, misinformation challenges. And this is also something that all of us would have seen. We see a lot of videos that get generated. Some of them are deep fakes, and sometimes these videos are so good that you are not able to tell whether it is a real video or it's a fake video. So it is very difficult for us to see how do we validate the information that is coming to us. We don't, most of the young crowd, most of the new people, they don't consume information these days from traditional methods like reading research papers or books. most of the information is consumed via I'll say unregulated and digital channels which cannot be trusted all the time. You get a WhatsApp message which says that this is how whatsoever has happened, and this is how rumors and all of misinformation can spread, and it can create a lot of law and order situation as well. So that's the problem with misinformation. Okay. Last but not the least is about privacy and surveillance. So people's data is very important. They should be given a choice whether they want to share their data, get some more personalized, hyper personalized recommendations, because otherwise once your data is up there on the net, then anybody can do surveillance on you. So that takes us to the end of module 3. We will start with module 4 in the next video, and I'll take module 4 in a couple of sessions. It has a lot of interesting things. I'm just thinking if I should do module 5 or skip module 5, because module 5 is all theory. It will talk about data governance and model governance and those kinds of things, and it is very, very theoretical. So even if I make a video, anyway you will have to go through the books and say that okay, the data governance is about this is how you look at data, but I will see that. So this brings us to the end of module 3.